We can use matrices to write or encrypt or decrypt secret codes, and this is called cryptography or cryptology. And so when we write a secret message, that's called encryption or encoding, and when we figure out what a secret message said, that's called decrypting or decoding. So you'll need to pause this video and read in your packet what cryptography is, and then be prepared to pause the video so that you can read any explanations that are a part of the packet. Okay, we're going to start by encrypting a message or turning it into code, the message love math. And so the first thing that we're going to do in step 1, we're going to convert all of these letters to numerical values. And so I've got a chart here indicating the letters of the alphabet and the numbers that they're going to be assigned. You could really do your own thing, but for all of ours we're going to use this very simple code here. So this is going to be our numerical values that we're going to assign. And so you see that we're going to give each of those letters a corresponding number going with that. And so there's our list of numbers. And the next thing we'll do is place the data into a matrix. The encryption matrix that you're going to use is going to be a 2 by 2, and we're just doing that to keep it simple. You could actually use any square matrix to be an encryption matrix, but we're going to keep it simple because we're not using a graphing calculator. So anything that, the way that we're going to put this into a matrix is we'll put it into any matrix that is however many rows and 2 columns, so that we'll be able to use it. So anything like that. So we're going to go ahead and use 4 by 2, and it explains on your paper that because we have 8 pieces of data, or 8 spaces right up here, we need to do a 4 by 2. If we only had 6, we could use a 3 by 2. If we had 7, we would have to use a 4 by 2, and we would use a 0 for the empty space at the end. So we're going to put that into the matrix. The next thing is we are going to find an encryption matrix. Now I can make this up, you can make one up. An encryption matrix can be any matrix that you can come up with. It just has to be invertible, meaning it has an inverse. So that means that it has to be a square matrix and the determinant cannot be 0. So you could make up any encryption matrix that you wanted. Now just so that we're all doing the same thing, I'm going to make up a matrix and we're going to use that. So the encryption matrix that I'm going to make up is going to be this one in yellow. The matrix in the purple that I've got here, that is taking these numbers right here and putting it into my 4 by 2 matrix as I did before. This is the encryption matrix right there. So that's going to be my code, and I just made that up. I did not do anything special. There's no secret formula to how to do that. I just made it up. I kept the numbers small, and I made sure that it had an inverse by making sure that the determinant was not 0. Okay, the next thing we're going to do is we're going to multiply our coded matrix, the one with our letters for love math in there, by the encryption matrix. So using multiplying matrices, and we reviewed that in the last video, we're going to do this. So we've got 24 plus 0, and so I'm just going to go through this real quickly. You might want to pause the video and make sure that you can do the multiplication just as a review. Okay, so there's what you have when you get all done. So pause this if you need to catch up to that. We're going to simplify those numbers, and so what we get right here on the right is we get this encrypted matrix, and so this is our secret message, so to speak. That's the code. And so what we're going to do in step number 4, it says now we're going to get a stream of numbers, and so we're going to have a list of numerical data. And so our numerical data in order is 24, -9, 44, 22, 26, 12, 40, 12, and that is our message. And so that's what we would send as an encrypted message, that the only person that would be able to figure out what that said is if they knew what the code was, what the encrypted matrix was. And so we'll talk about how to decode it in just a second. So let's try another one. Just by the way, if you used a different encryption matrix, so if you would have made up a different matrix than the one that I did, instead of the 2, 1, 0, -1, if you would have made up something else, then your code, your stream of numerical data would have looked different, and that would be fine. But so we all have the same thing. We're going to do this the same way. Okay, we're going to encrypt the message help me, and we're going to use this matrix. So again, this matrix right here, I just totally made that up. Just made it up. There's no special anything to how I got that. I just made it up. we're going to use that as our encryption, and this is our code. And so I would send this to somebody that I wanted to be able to crack the code so that I could send them secret messages and they would be able to figure out what I was saying. So somebody else might have a different code. Alright, so what we're going to do is we're going to take help me and we're going to use this chart here with our letters and numbers to make a matrix. So the 8 comes from H is 8, and the 5 comes from E is 5, and so on. And so I just make that matrix. And then I'm going to take that matrix and multiply it by my encryption matrix. So this is my encryption matrix. Help me is from those letters right there. And I'm just going to multiply that. So here again, you probably want to pause the video right now so that you can do the multiplication and make sure that you're getting the same thing I'm getting. Okay, so here is the version before I simplify it, and then once I simplify it, I have a matrix with my numbers. And so if I write it as a stream of numerical data, or my code, or my encrypted message, it's going to be 3, 26, negative 4, 56, negative 13, 26, 5, and 10. Again, you need to pause this video and make sure you understand how to get these coded messages and go through it, and you might have to listen to it again, and you might have to go back and read the directions and read the steps again. Okay, number 6 on your notes, we are going to encode the message rain. And so we're going to just take that, and I'm going to use this encryption matrix again, just I made it up. And so we're going to go ahead and do that. So if you want to pause the video right now and see if you can get there by yourself, that would be a really good idea. If you can get all the way to the encrypted message, the same one I get, then you've got this. Okay, so what I did was I assigned the numbers to each letter according to my alphabet chart. So R is 18 and A is 1 and so on and so forth. And then I'm going to multiply that matrix with my encryption matrix. And when I get done with that, I have 19, 34, 23, negative 10. And so I would write that as a stream of data. My encrypted message would look like this. So you just write it as a list of numbers separated by commas. And so that would be my encrypted message. So if I sent that to you and you had the code, you had the encryption matrix, then you would be able to know what I said. Alright, the next thing we're going to do is now we're going to read the steps how to decrypt a message, meaning go backwards. So if I sent you a message and you wanted to know what it said, you would have to be able to decrypt the message. And so you have to work backwards. So stop the video, read the steps to decrypting the message, and then press play again. Okay, so for example number 7, if I send a message 18, 13, 44, 28, and you already know that the encryption matrix is this matrix, and that's probably because I secretly sent it to you a different time, because we wouldn't want to send them together because then anybody could crack the code, then you could figure this out. But we have to remember that because we're decrypting a message, we have to use the inverse. We're going backwards here. So if the directions say to decrypt something, you have to take your encryption matrix and find the inverse of it. So I'm going to find the inverse of this matrix. So again, in video number 3, you were supposed to review how to do that. So finding the inverse of that matrix. Once I found the inverse of the matrix, this right here, that is my decrypting matrix. So that's the matrix in orange there that I'm going to use to figure out what that message says. So what I will do is I will take this list of numbers and I'll put that in the matrix. I will take my decryption matrix right there and I will multiply them together. And so make sure you understand how everything is set up. On the test you will need to be able to do both coding the message and decoding the message. You will have to do them both ways. Alright, so our end result is 8, 5, 12, 16. So what does that mean? So I would need to use my alphabet chart, and I'd write the list of numbers as 8, 5, 12, 16, and then using my alphabet chart I'm going to find out that 8 means H, and 5 means E, and 12 means L, and 16 means P. And so that means that my message is help. Okay, the next one, decode the message 40, 19, 28, 9, 50, 11. So you should pause this video and decode the message, get the message, and then you can play the video and make sure that you get the answer. Okay, the decoding matrix, we need to find the inverse. So you should have found the inverse, and that inverse is 0, 1/2, 1, 0. Right there. So you're going to use that by multiplying this set of numbers from that matrix times the decryption matrix, and then you would get that matrix right there, which simplifies to be 19, 20, 9, 14, 11, 25, writing it as a list of numbers right down here, and then use my alphabet box to decipher what that is. And so when you match up all the numbers with the letters, the code is stinky. Just a couple of reminders as you finish this packet. When you see the word encryption or encode, that means you're going to write a secret message. And when you see decryption or decode, it means you're going to figure out what a secret message says. Depending on which way you're going with this, you need to think about, are you going to find the inverse of the matrix or just use the matrix as is? Please come and see me if you have any questions, and make sure you come and see me early so that we can get those answered.